A company producing jigsaw puzzles has fixed cost of $6,000 and a variable cost of $2 per puzzle. The company sells the puzzles for $5 each. So let's build up our functions. First, let's consider revenue. Our revenue function, as a function of the quantity sold, would be R of Q is equal to 5 times Q. That's price times quantity. The cost function, C of Q, will be equal to the fixed cost, 6,000, plus the variable cost, which is the variable cost per item, times Q, the number of items that are produced. So here we have a revenue function and a cost function. Now let's consider the break-even point. The break-even point is the level of production at which the cost and the revenue are equal. And so if I display these two functions on a graph, consider the revenue function, and then we have a cost function. So the point of intersection, or the break-even point, is represented on the graph here. This would be at a quantity of 2,000 units and a revenue and cost equaling $10,000. We can arrive at this solution also by setting the revenue equal to the cost. So we would have 5Q is equal to 6,000 plus 2Q. And if we solve this, we would get Q equals 2,000. Let's further consider the profit function. I'll let profit be P of Q. So the profit, if we both produce and sell Q items, would be the revenue from selling Q items minus the cost of selling Q items. And so you'd end up with a profit function that was 3Q minus 6,000. If we were to graph this, we would have a function that looks something like this. And again, note that we break even when profit is equal to 0. So it should go through the point 2,000, 0 on our graph, which is the exact same quantity at which the revenue and the cost were equal above.